I'm Daniel. So today we've got this quite interesting surgical stapler that we're going to have a look at today, which I acquired quite a while back from a local hackerspace. This appears to be the first smart surgical stapler, according to its brochure. So basically you use a surgical stapler to close wounds, tissues, and organs during surgery. Apparently, this model is supposed to adapt to tissue variability during operation and provide audible and visual feedback, again, according to one of the brochures. In this video, I'd like to get this staple here to boot up. So I'd like to display something on this built-in OLED screen here, but it is unlikely that I will, as it appears that a capacitor has come off over here. And the staple also seems to have like a built-in expiry date after which it can no longer be used. So even if I get it to boot up, I wouldn't be able to test it out much, which is okay, as, you know, I don't plan on doing surgery with this, you know. So, enough talking. Let's get started. So, what I'm going to do is I'm going to use one of my two-cell LiPo batteries here, and solder on a female connector to these three terminals, to these three wires over here, positive, negative, and I believe this is like one of those like middle wires that use to test. I don't know. Okay, yeah. So I'll go get the soldering iron started and let's go do that. Okay, I'm done with that. So let's go connect the battery and see what happens. Fingers crossed, everyone. Okay, nothing on the LCD or anything. Let's try buttons. Okay, no indicators, no anything. No, nothing. Okay, doesn't work. So, as it doesn't work, let's go reverse engineer this thing. Okay, so let's start reverse engineering here, from the bottom here. Now, I did manage to find this part here, which unfortunately got ripped off of this part here, of this assembly here, and basically it's just some little flex cable here that runs from here, runs from this circuit board here over basically like this thing has like a charging dock with a whole bunch of pins here, and this is like what it all connected is, just a bunch of contacts for it to connect to, a couple of random components here. I don't know what those are for. Some stuff here, like basically about the size of the battery that this had. Is a 7.2 volts, 2.05 amp hours, or 14.8 watt hour battery here. Okay, now moving on to the next thing up here. Okay, and here we have basically some sort of like power voltage regulation type stuff here. You can see like this is where like the battery is connected to the system here, and basically, you know, like some very large capacitors here, you know, MOSFETs and inductors and stuff here, just general like switching stuff it seems. This here is more switching stuff around the back, and just more like power management stuff around the back in general. And this chip right here is a Texas Instruments TPS 43000 DC to DC control. Yeah, again, just like more power management stuff. Has this kind of like cool kind of like board to board interconnect cable here to this other board here. This is really called like the gas gauge. This is just like a battery management board, basically like to manage the battery. Here you can see some like thermistor type thingies here to monitor the battery node, diodes, stuff. This is a BQ30Z554 like 2 series, 3 series, and 4 series lithium-ion battery pack manager. Again, kind of interesting there. Now this part here connects up to here, right? And this is where things start to get a bit more interesting in general. Probably not the most visible here due to all these wires, but again, basically this here is this is basically like a motor control board. Yeah, you can see like all of these like brushless motor controllers here, all these surrounding components. These are A3931 brushless motor controllers and MOSFET drivers here. These things here, like these arrays are like 6 MOSFETs right here to control these, which are like these brushless linear actuators here. They're the the number is B0512N4094 here, and there's 3 of them here. Basically, they're what drives the surgical stapling here. There's an end here, and this is like, and they connect to like a little. They connect to a thingy that goes, the actual stapling thingy that actually goes does the surgical stapling, you know? Cool. Here, like, again, there's 3 separate units here, 3 separate controllers, controls and like peripherals and stuff here for each one of these. At the far end here is a Match X02 4000 PLD here, programmable logic device. Basically, I assume to control all of the brushless things, considering like FPGAs and stuff. Generally very good at that kind of stuff, you know. Again, here, returning back here, here's just some controls here, some buttons, just generally to control the device here, you know. Here's some connector. Here's basically just a connector for, again, the actual stapler unit here, because like it's like automated kind of mechanical stapling and stuff, feedback, you know. I'll show up the brochure that talks about this stuff, that talks about this on your screen right now. Yep, and here we basically just have like a central processing board here, CPU board here. Nothing much interesting on the bottom here, except this thing. Not sure what it is here. AT1620 TW1 TWIRPUI plus 16. H, not sure what that is. Capacitor here, and probably the most interesting thing on this side of the board here is this MicroSD. Is this MicroSD card slot here with an 8GB MicroSD card in it. Basically, this isn't really accessible from the outer shell. And I believe it's just basically just like used as storage for stuff. There is some stuff on this. I've looked at it. I'll show it soon. Again, a micro USB port. This again is user accessible. Not really sure what it's for though. And moving on to the top side again. Okay, so here's basically the main SoC for this device here, which is a MK20 FX512VMD12 MCU here. You can see it there. Now we have some supporting components. This is some RAM here. here, not sure. Okay, this is like this is like a quad SPST switch. Quad SPST switches here, not sure what this is. This is probably some SN74LVC573A Octal transparent D-type latches with free state outputs. And just like some personal research here. Not sure what this is. Here's actually some interesting stuff here. There appear to be a couple of debug ports here. I think one might be JTAG or something, and the other one is some sort of, I think it's more like specific to these particular types of, this particular brand of SoCs. I forgot what it's called. I'll probably show some stuff on the screen about now. Some interesting like bodge wires and stuff here. Not really exactly the kind of quality and stuff you know you want from a medical instrument. Although it's not like it's life critical or something, you know. So here's again another bodge wire. Here's I'm not sure what this is. I think it's some sort of like IR transceiver type thingy, I think. But again, not sure. Maybe to communicate with other stuff. I haven't really seen it. Like when I was looking for the broaches and stuff for this device, I didn't really see much in relation to it. Here again, here's a little small, I believe 1-inch OLED, I think. Display here in this little bracket. Couldn't find anything for it, but I'm just going to show all the stuff up here. Maybe the viewer will have some luck with finding something. Any sort of data sheet or anything seems something interesting that could probably be reverse engineered. Again, probably like uses UART or I2C or something, considering that this controller is capable of that. Obviously, no, nothing particularly advanced. Not really much else here on this side of the display. Again, actually, just gonna go back to this motor control module. Again, there's this interesting part here highlighted J9 and a couple like some pads here next to the FPGA. It's PLD here. Possibly some sort of like programming type thing. I don't know. Kind of interesting. I'm not really going to do any tinkering with that. But if someone here has it, you know, just pointing it out that it exists. Again, yeah. Top thing here is basically it's like a Wi-Fi module here. It's a RN171 2.4 GHz wireless LAN module here. Basically just a little thing here attached to a small antenna. Not really much on this board here. Just a little module that slots in. Kind of cool. There. Now let's have a look at the files in that MicroSD card that I talked about earlier. On the home directory we have 4 folders and 2 files. Let's start with looking at the file name synopsis.txt. It seems to just be a list of every data log and the date and time of when it was recorded. Interestingly, all of the logs are from either 2013 or 2018. Now let's have a look at the blb file. Not really sure what this is for. Seems to be a bunch of version numbers at the top. While most of this just seems to be random hex data, there are some text strings scattered throughout here. There are a lot of references to EGIA, which seems to be short for endo-GIA, which apparently refers to a type of surgical stapler. There also seem to be many references to EGIA artic, artic probably being short for articulating, and this seems to refer to a type of surgical staple reload that can be used with this stapler. Also, I keep seeing some references to FPGAs. That thing that I called a CPLD isn't actually an FPGA. Not sure, but whatever. Now let's look in the settings folder. Let's have a look at motest.kvf. Not really much here, seems like it's for motor test settings. Now let's have a look at handle.kvf. Seems like it's for the power handle settings. Remember the device that we were looking at before was the power handle. There seem to be some references to a C3 board. Not sure what that means. Maybe some particular version of a PCB in this device? Let's look at EGIA-rel.kvf. The rel probably stands for reload, and if so, then these are settings to the stapler reloads, which is probably where all of the text here seems to be motor related. This file is apparently for dyno settings, although I don't know what is meant by dyno. Now let's have a look at 802.11.kvf. Not really much here, this is probably settings for the Wi-Fi card. Nothing in the lost directory. Now let's check out the archives folder. This folder probably just stores older data logs, not really sure. And now let's go look in the data folder. This is probably for like data logs and stuff. Let's start with signals.txt. Just seems to be a bunch of status messages. Now let's go to eventlog.txt. As the name suggests, this is probably an event log. Seems to be quite a bit of stuff about verifying the battery with the 1-WARC protocol. Maybe the yellow battery wire was a 1-wire bus? Not sure. Also more stuff about a C3 board. Also some random secret address? Not sure what that's about. Let's now look at the eventlog.gen2 log file. Not really sure what this is. Maybe it links to some other addresses and then it makes sense. Nothing in the archived file. Nothing particularly interesting in the 802.11.kvf file. Let's look at another data log subfolder. Let's just look at the event log file. This is pretty similar overall, and in both event logs there seem to be references to a test fixture, which is kind of interesting. Now let's look at the different data log altogether. Interestingly, this one has a lot of numbered .rdf files. Let's open one. It mostly just seems to be hex data. Yeah, I think this is all that we'll be exploring today. Yeah, so that concludes our reverse engineering session here. Unfortunately, due to this not being in working condition, I can't really do much more in-depth reverse engineering of this. And honestly, even if it was working, I don't have the skills or resources to do that kind of work anyway. It also just doesn't feel worth it personally, as my time can be better spent doing other things instead of working on a device that literally has a built-in expiry date, you know. But if anyone watching this feels like doing more reverse engineering on this for whatever reason, feel free to. I can also provide more information about the device. I'm not going to do any more serious work myself on this device as a whole. Despite that, I might do a video in the future, or I try to reverse engineer this OLED display here, and you know, here I have quite a few parts I can reuse for other projects and stuff. And so that's it for this video. Please consider liking, subscribing, enabling notifications, and leaving a comment down below this video. Feel free to give any feedback. Bye now.